afternoon, everyone. Thank you so much for joining us today. My name is Alex Kosmiter. I am the youth coordinator here for the University of Arizona's Cooperative Extension Waterwise program here in Cochise County in Sierra Vista. And I'll be helping to facilitate this talk today, which is the water we rely on, and we will be talking about groundwater and aquifers. And our speaker today is our very own Mary Ann Capehart. So let's see. There's Mary Ann and there's me. So Mary Ann is a fellow coordinator here at the Waterwise program in the University of Arizona Cooperative Extension, Cochise County, where she helps the community embrace waterwise practices like conserving water indoors, collecting rainwater, using gray watering, xeriscaping, and understanding the state of their watershed. And that's exactly what we will be talking about today. All right, I think that we are ready for you to take it away, Mary Ann.
Right. Yes, today I'm talking about aquifers and groundwater in Cochise County. And this is not an in-depth analysis. I am not a hydrologist. I just wanted to put that disclaimer in there, but I am trying to communicate today the basics so people have a strong understanding of sort of the paradigm of what groundwater is and what aquifers are. So that's what we'll look at, and then we'll go local. So yes, we're going to talk about aquifers, groundwater. Recharge, a lot of people wonder, how do aquifers fill up with water? What is overdraft? Cone of depression is kind of a big thing in this area regarding pumping. And then we'll look at the well registry map, and then we'll look at the monitoring or index well map. This is a glossary. This would be great if you wanted to go through this slowly once it's on YouTube, but you can see, let me look at alluvial, because that's our area here. We're in the Basin Range area. And so we have sedimentary deposits on our open valleys, and they get quite deep. And that's from many millennial. And base flow is the part of the river that comes from groundwater. And for desert rivers, that's the main source of water outside of the rainy season. So it's extremely important, that relationship between groundwater and rivers here in the arid lands. And it's not really represented well in law. So that makes things difficult, sometimes protecting a river that is based primarily on base flow. We're going to talk about fissures and subsidence. Hydrograph is a graph that shows the level of the water at a particular date. And oops, there we go. Overdraft is when you're not at sustainable, or what's called safe yield. You're taking out more than gets returned by recharge. I'm not going to do everything, but I'm just kind of breezing through. Permeable has to do with how much and when and where recharge happens. So how porous is the material that the water's moving through after it rains or snows. Porosity is the space in the material. And the vado zone is what's right underneath the surface of the ground through which water travels before it gets to the aquifer. So there's no quiz, but it would be awesome if everyone went away from this talk with a clear idea of what an aquifer is and what groundwater is. So aquifer is a little more general. It's a formation that contains materials that is capable of storing groundwater, usable amounts of water, and in particular so that it can be pumped out of a well. Nice word, aquifer. An underground formation transmitting usable quantities of water. Here we are. Now this is good, we saw this earlier in a different color. This is a good representation of our local area with the mountain fronts. That's where you get a lot of the recharge, right at the foot of the mountains. And then you have the vado zone, and then you have the water table, which is the top of the aquifer or the groundwater formation. And then you have various sized materials through which the groundwater travels. Yeah, there's we're going to put up a link for the well owner's guide. If you don't have one, you can get one online. I also have hard copies, and it's a really wonderful publication. So there's the water table underneath the vadose zone. And then you have the sediment through which this is traveling. And then when it gets saturated, it's called the zone of saturation or the groundwater area. And then below that is bedrock. So that's kind of a very basic picture of groundwater. Groundwater is not a river underground. And I know Alex spends some time with children trying to explain that it's not a river, it's not a lake. Unless you're like in Florida and you're in caves and in limestone formations, it's just a lot of water saturating the materials underground. This is also our area. So you can see a lot of the recharge happens because a lot of rain happens on the mountains. And so it has its first opportunity to sink in at the foot of the mountains. It's called mountain front recharge. And then it moves slowly through the groundwater to, in this case, the river, which is at the bottom of the watershed. That's what makes a watershed. You have the rim around, and then you have all of the slope goes down to the base, the lowest point in the basin, and as the groundwater moves to a river frequently. But how long and when and where is very hard to describe, and actually has to be, looked at the various measurements because we can't see underground. That's one of the challenges we have to understand how we are recharging our groundwater. What's the material under there, and how fast or slow does it move and to what depths? So here's a picture of a well, and you can see it's intercepting the movement of groundwater. And here's this even simpler one. We have the surface water, unsaturated water table, and so forth. So groundwater exists underground in saturated zones. The upper surface of the groundwater is called the water table. It's found in pore spaces of geological material. So yes, there was a paper written by someone in the education department about not using blue for groundwater because it confuses people because they think it's like a lake or a river underground, which it is not. But blue is universal for water, so there you go. Here is a really great graphic that is regarding well placement in a publication, but it kind of shows you also the layers. And so you see the recharge going through the vadose zone. And then in this case, there is a lot of rocks that have cracks, so that the water must move through these cracks, and that can take a very long time. And so that's the first surface of bedrock. And then you have the main water is existing underneath that. So every situation has unique formation. That's why some people might be up a little bit towards the mountains and they have what is called a perched aquifer. So it exists on a higher level than it might in the valley. And so they have the good luck of having access to that water where someone a little lower down might not be doing so well regarding the level of their water table. So as I said, recharge is hard to measure, and groundwater recovery is hard to predict. We want to sustain our groundwater for future generations. We want to keep it sustainable. We don't want to take out a lot more than that's going back in through recharge, which is when rain, snow, and so forth goes back into the groundwater, into the aquifer. So that's the goal. We're not really achieving that at this point in our valley here in the Sulphur Springs Valley. But you can see also that it's a very important part of sustaining a river in the San Pedro Basin. We need that water to come and enter the groundwater at a level where it intersects the river. If it goes too low, the river is not going to have its base flow. Okay, so this is the different kinds of material that can exist underground. So you can also find this in the well owner's guide. So you can see that it's quite different depending on where you are. And there's that fractured rock we looked at earlier, and limestone, limestone and various different materials. And the permeability is how quickly water can move through the material. So that also has a lot to do with recharge. So you see the different materials here and their permeability. And if you look at the rock, for instance, in the bottom right corner, water flows through fractures a foot 100,000 years to 300 feet a day. So it's very variable. And we have had a lot of studies done in our area. So the information is there. But it's always could be more complete because things change as you move across the valley. You guys, here's another visualization of recharge. Charging up that aquifer, putting the water back. And you can see that depending on the materials and so forth, it can take millennia to get to the lowest areas, which is why they sometimes call that water dinosaur water, because it was put there way back when. I want to say Pleistocene, but I'm not sure I'm pronouncing that right. Pleistocene. If anyone has a pronunciation, you're welcome to say that. All right, so there we have a very nice visualization of various levels of the aquifer as well. And so it's the top level it moves laterally, but it's confined below. Then you have several other layers. They also call that aquitard when there is a confining layer. This is a fun map that also kind of shows the type of difference between how a aquifer is recharged and how long it took to form the aquifer. So we can look in the Tucson Basin, it took 300 to 8,000 years. Why the different numbers? I imagine it depends on where you are in the aquifer. So it can take a very long time to recharge. That basin down there is very old, 12,000 to 25,500 years. This is a map of dry wells in Arizona. Now, this is not a good thing. This is when the water table has dropped below the level of the well and the well has dried up. And most people do not report their wells when they have dried up. And that would be a great thing if people were more active that way and reporting their wells. We would know more about the level of the water table and the state of the aquifer. But this is the ones that have been reported or discovered through our well sweeps. Okay, so we're going to talk a little bit about the difference between surface water and groundwater. Watersheds are things that exist at the surface. Groundwater basins are what's underneath. They often reflect each other. If you have hills or mountains, they will most likely go below ground, creating a very similar outline for a groundwater basin as you would have for a watershed. And I'll show you a little bit more about that when we get into the maps a bit later, but yeah, you can see the different groundwater basins in our area. There's the Upper San Pedro, there's the Douglas Basin and the Douglas INA, which is a irrigation non-expansion area. There's the Wilcox Basin, there's the San Simon Valley. It's a different basin. I'm not exactly sure what the name of that basin is. And then you move on to the lower San Pedro. You know, the San Pedro runs north. And there's Santa Cruz. So that's a nice map for understanding the groundwater basins existing below the watersheds. So you can identify your basin. Which basin do you live in? So it looks like most folks today are at the Upper San Pedro Basin, some in Douglas Basin, and some in Wilcox. Great spread.
MaryAnn, what does, I can't tell, the Bisbee area, what does that fall under?
That's such a good question. I actually have an awesome map for that because Old Bisbee falls in the Douglas Basin.
Okay.
So those peaks are facing the direction which would take it into the Douglas Basin. But out here where I am actually today in Warren, outside is in the San Pedro Basin. So it depends on where you live. You can kind of follow 80 up, and on the left, as you go past Old Bisbee, is in the San Pedro Basin. But most of Old Bisbee is in the Douglas Basin. All right, good question. And I have a map if anybody wants one. I can send them of those exact outlines a little closer up than this map. I'm not going to get into too much detail about this, but this is just a little understanding of the relationship between groundwater drawdown or overdraft and rivers. At a certain point, it pulls the water away from the base flow of the river. And you can see it sucking the water table down around that pump. Okay, the phenomenon known as the cone of depression, kind of ironic word. So as the pump works, it pulls down the water table, and if your other well of your neighbor or someone else is in that cone, they may lose their well. And it also draws, as I just explained a little briefly, water away from the river. So that's a very big issue here in the San Pedro River. We have quite a large cone of depression around Sierra Vista area. So here we have another illustration of that. We have the original water table. The overpumping is starting to create those cones of depression. And pretty soon the little red barn pump is not going to have access to water. And the stream has dried up. Here's another last one I'm going to discuss about rivers. They're called either gaining or losing. So the water sort of probably like pre-development would just flow through the aquifer to the base of the river. And then when you have pumping, it starts to pull it down away from the river. And when you actually have a lot of pumping and that cone of depression gets deeper, it's going to pull almost everything away from that base flow of the river. So it's called a losing stream. So that's the river groundwater relationship. Then we have the other issue, which is more in the base, the valley, the big valleys. We have no rivers in the Wilcox Basin, for instance, or the Douglas. So we're pretty dependent on our groundwater there. We're very dependent. Really, the only other source is some recycled water. And so the lowering of the water table has pretty severe consequences for people whose wells aren't too deep, and they may have to deepen them if they can afford it. It can be quite expensive to deepen a well. It could be 30 grand to deepen a well, depending on how deep you need to re-drill it, which is one of the reasons I've been promoting larger scale rain harvesting as an alternative to deepening a well. because honestly, you may not know, I might have to deepen this again at some point if the water levels continue to drop. So here's, some of the hot spots in the state. This is not brand new information, but it goes to 219. So you can see the average in the basin is quite severe. In the Wilcox Basin, it's 28 feet. I'm sorry, 28 feet. And then the largest area, the largest single decline was 91. So that's an index well. I'm going to show you those in a bit. So they have levels measured by these index wells. Okay, another side effect of overdraft, which is taking out more water than is being put back in and having the water levels drop severely, is fissures and subsidence. I know Alex is been popping up some links. We partnered with the Copper Queen Library to have someone come in, Joe Cook from the Arizona Geological Survey, to talk about that. So you can find that link and check out the video of him talking about this unfortunate relationship between groundwater decline and these cracks, which sometimes don't appear as deep as they are. And they're pretty scary. You might have been reading some of the press about that. During the rainy season, we had some fissures combined with erosion during some of our bigger storms. And these happen because the land is sinking. Once the water goes out of those pores that we looked at earlier, the land just kind of collapses. It's pretty hard to, I would say it's 90% impossible to fill them up again. Once you have that sort of subsidence, you can really pump it up. But I think that like anything with groundwater, depends on where and when. But if the level of the subsidence is different between two areas, one will sink lower, and that's what you get, these cracks, these fissures. So that's not a great side effect of groundwater overdraft. And you can see the map there on the right, different degrees of that subsidence in that area. So yeah, you get the light yellow is 1 centimeter, but it gets quite a bit more severe in the darker colors. So this is to demonstrate what's causing some of this subsidence and fissures. So you can see that there's quite a bit of drop in the water levels. This particular site went from about 200 to over 300 feet. So the water was available at 200 feet. Now it's, around 100 feet deeper to access that water. So this is an Arizona Department of Water Resources index well, and we have what we call hydrograph. So you can see that happening over time. Each hydrograph has a different time scale depending on when they checked the levels. So you need, if you're looking at these, to look at the dates. And so this one went from quite early, 1982, to it looks like it's probably 2020 or so. And there's more information on these on their website. You can actually see like the exact dates of when they took the measurement. Those are pivot irrigations. So that's pulling up groundwater, and then you have the long arm that sprinkles the fields in a circle. So that's a picture of those. Here's some more hydrographs showing similar declines, and we do have mostly declines. There's a few places, and this is the Wilcox and the Douglas basins. There's a few places in San Pedro I know that are coming up. And if you look around Tucson, you can see that things are starting to come up because of them doing some infiltration of the Colorado River to boost groundwater there. But these guys don't look too good. So that brings me to the map part of this presentation. And this is the Arizona Groundwater Site Inventory, where you can look at monitoring wells. Because we're not asking users to measure their use or their well levels, which is done in other places that have what you call active management areas, not residential wells, but the larger wells. So there's two kinds of wells. There's exempt and non-exempt, meaning exempt from having to report. The non-exempt is larger than 35 gallons per minute capacity. So that's how they're differentiated. So a small residential well or even a small well on a farm, maybe using for livestock watering, would not be that large. So I'm going to go into this map briefly. And can you see that map?
Yes.
All right, so I'm going to go over here. So if anyone's interested in, hey, I want to find out what's happening nearby me in an index well or a monitoring well, they're called, I can check it out just to have an idea of how water levels are looking. And I'm going to turn this into, I'm going to put that as all. And I'm going to use the base map imagery hybrid. And I'm leaving their layers intact. And I'm just going to zoom in. All right. There's other ways of searching. We're just going to zoom in. And we'll go over here in the wildlife refuge and click on this one. That's an index well. And it has the information regarding its ID, and you can, look again if you write those things down, and the ID number. Although I've been having trouble searching with that number as of late, so sometimes these sites don't work as well as they do at other times. They just kind of come and go with some of the search features. But so the last level at this site was 11/3/2020, pretty recent. Here's a hydrograph. So this is looking pretty good. So they've gotten a lot of recharge, and it's kept the water level around the same level. I can go over here, look at this one. So this last one was 11/3/2020. And we'll look at the hydrograph. This one's not looking so good. So yeah, it's gone down to 260 feet from 125 or so from the 50s to very recently. And I can look at well information if you want to know a little bit more detail, what basin it's in, exactly where it is, if you wanted to compare it to your own location. It's Sometimes there's pump records or water quality issues are represented, and there's a photo. They don't look like that much from above ground, but they tell us a lot. All right. Let me open it up for questions at this point. If anybody has anything they wanted to ask me about this map. You could unmute yourself, I think, or maybe Alex needs to unmute you. Any questions? I'm not looking at the chat. I could look at the chat.
So far, there are no questions in the chat, but you're welcome to unmute yourself if you have a question.
All right, let me show you another feature on this. So as I discussed, there's groundwater basins and there's watersheds, and they are often similar, but they're not the same. You know, as you go north of Tombstone, you get the shift between the upper San Pedro and the middle San Pedro watersheds because of formations there that extend underground, and that changes that watershed. Let me show you the watershed feature. That gives you a nice map of the watershed in orange. And you can, you know, kind of see where you're at within that watershed. So that's a nice feature of these mapping features. Let's look at the basin. This is the Wilcox Basin. So that helps you know where your groundwater limits, boundaries are. So we have basins and we have watersheds. I hope everybody's clear about that. And there's other features here. Sometimes you can use a site ID or a local ID once you've identified something that you want to check back on. All right. So let's go back to my presentation on this. See if it's not quite as volatile. Here we have the other website I wanted to have you become familiar with, which is the Registry of Wells. And I tried this a couple of times today, and it doesn't seem to be working right now, which is not uncommon for the ID numbers. But that's one way to go. If you had a well ID number, if you have a registered well, you could find information about your well if you had never looked for that information, if you'd bought it, the land or something, and hadn't really looked at your well depth and so forth. So these are some examples of well levels at these areas, and you can see some of them go quite deep by large agricultural interests, digging quite deep to get that groundwater. They have the money to put down a deep well like that to guard against further overdraft. All right, so we're now in this one. There's quite a bit going on here, but I think I'm gonna stick with the screen as it is. Okay. Yeah, I hope you can see enough detail. I asked Nicole to be on standby in case the maps got temperamental, which they have, but we'll do what we can. I'll go by basin right now. You can see there's a lot of wells. A lot of wells in Arizona. As I said, we're primarily dependent in our county on groundwater for our water source. So of course, we're going to have to throw down a lot of wells. And fortunately, I think we have to think about, should there be some kind of limits or not on how much water can we take out safely for our watershed, for the sustainability of our aquifer. So as I said today, this isn't really giving much information, and I'm sorry about that. Normally you would see a lot more information. Just might make sure that the map has loaded. And if anyone wants very badly to look at their well, please call me and I will help you walk through that when the map has kind of righted itself. Make sure the layers. Yeah, the well registry layer is not really working today. We can get something going on with this. But this gives an awful lot of information. It doesn't have a hydrograph for these wells, but it does show you the ownership. It shows you the depth, often the licensed driller. The only really thing you need to do in Cochise County to have a well is just to have a licensed driller. There's no other regulation about how close it needs to be or far it needs to be rather than someone else's well or anything like that, or proximity to a river, for instance, generally speaking. So that's that map. And again, if you have a well registry number, when it's working a little better, you can search by the well ID. What time, how are we doing? We're doing pretty well on time. Here are some more pictures of agricultural areas. And you can see with the red dot in the well registry, you can get the owner. Now, what kind of well? Is it exempt or non-exempt? So exempt means it's 35 gallons per minute or less. Non-exempt, this has to do with other areas of the state. Non-exempt for measuring and reporting in what we call active management areas, which are in Phoenix, Tucson, Prescott, there's one in Santa Cruz. Those have to report their usage so we can have an idea of what's happening below the surface, how much water is left, how fast are we using it, how deep is it, and try to have some management around that, which is an active management area, which we don't have here. It just didn't happen when the 1980 Groundwater Management Act was put into law. The rural areas were not part of those management plans. So you can see here, and there's other details regarding the wells, but it's public information. And so that's, if you're a map person, pretty fascinating stuff. And if you want also to know more about areas around you, also pretty fascinating stuff. So Now, the last thing I wanted to talk about was water quality, and not getting into it too much, but I think one of the reasons we have a lot of interest in our agricultural lands in Cochise is that the water is quite fresh at deep levels. And sometimes you have a very briny water down there. So that's a problem for other areas. It gets salty and over mineralized below the surface, but here we have quite fresh water at depth. And so that's something that is discussed. You can look on our website for other discussions of our groundwater. Alex has put up some resources regarding the topics that we talked about today. And I highly recommend Laura Condon's Water Beneath Our Feet. It's a really good a video regarding Arizona groundwater and its relationship to surface water too, rivers and lakes and so forth. So that's an awesome thing to watch. It's really, really well done. So let me see if there's any questions. Do we know about the actual depth of the water in these basins and the quality of water? Okay, so yeah, the quality I just mentioned is very good in general in this basin range valley. That's that. Now, in terms of depths, there are studies for the Wilcox Basin that estimate depth. Of course, it varies where you are. There are other places where they only measure to 1,200 feet. So their estimations for sure. And I can't give you a number of what we have in the aquifer. There's estimations, they're a bit dated, the ones that I've seen, so I don't want to quote those from 2016. But you can understand if some of these large agricultural concerns are throwing down a well 2,400 feet deep, that you know the water goes to that point or more. So I hope that helps answer that a little bit. Do they map the topography? I have not seen any maps of the topography of the basins. I think there's a gray satellite that can map water depths based on minute differences of mass, which are due to prevalence of water or not. But I haven't seen any actual like topography maps, but you could look into the gray satellite imagery that might satisfy some of your curiosity about that. GRACE. And I'm sure the technology will catch up to that at some point. So Christy wants to look at Palominos Road. So I would imagine I'm going to go back into this site. I think she probably wants to look for
Well, because
a
it used to be,
monitoring well.
used to be agriculture. And then they shut down the agriculture and let it be built up with homes down there. So just wondering if it increased at all, and then they have, started recharge projects there, Mary Ann, too.
Yes, and I'm glad you mentioned that, because that is one of the things that's being done to improve our groundwater, is to take stormwater runoff coming across the land and funneling it to an area where it will have some impact on the base flow of our river. And that's an important thing that's happening, called the Cochise Recharge Network.
Better than in Palominos School.
Mm-hmm. Yeah, they were working with the runoff there. That was problematic. So I'm going to come down here.
I was thinking just north of State Route 92, you know, in that area.
Mhm. Is that the closest we're gonna get, do you think? Can you see that blue dot near, kind of below Wachuca Terrace? Or should I go farther west?
Same thing, bro. There.
Yeah.
How about this guy?
I was thinking more west over toward on the other side of the river there.
Here we
'cause,
go. This is a good one.
Yeah,
on the
straight
other
up
side.
Palominos Road is where they used to have a ton of farms in the 80s even.
Yeah, that was a wonderful way to help the rivers to retire some of that agriculture. Oh,
Just
well,
wondering,
something.
yeah, did those water levels come up any? We had some wet years still.
So we're at the intersection here of South Palominos Road and 92.
That'd be good.
Looking good. This map goes from, oh, it's not very old, 2001 to probably 2020. Depth to water, 41.
Yeah, that is a dry period as far as drought, you know.
This depth to water is 40. This is a spreadsheet of the water levels by year, so you get a more accurate sense of the dates.
Oh, yeah.
It goes from 73, the depth to water was 40 feet,
Right.
to 2020, a dry, yeah, got a little, actually a little shallower by 0.3 of a foot.
Great.
Thank you for that question. That was great. Anyone else want to look at a location? Be happy to do that. And again, you could write down this ID and attempt to search by that at another time. I can try, but it just doesn't seem to want to do that right now. Oh, did it. Get a very accurate idea of where that is. Anyone else want to ask about a specific location?
There's a great question in the comments on if you live in the city and don't have a well, where would you look to determine the level in your area?
That's a very good question. You would look for an index well that's nearest where your water supply is being pumped. You may not know where that is. That's something you could ask your water company. Where is our water being pumped from? For Bisbee, it's the Naco Bisbee well, and one would look for the closest index well. Now, that doesn't tell you exactly how deep the water level is for your water company's well, but it gives you some idea. Yeah, so let's see. Does that person want to identify where their water company, what the
That person was me. I was just curious. I can find out where my water company is. But we do also have a question. Can we talk about Tombstone taking Wachuca water? From Christy.
Why don't you comment on that, Christy? I know that
It just, it just seems, it seems excessive when you go into not only Carr Canyon, but Miller Canyon and many areas. It'll be dry, it'll be hot, and you can hear the water leaving the mountains where it should be recharging to the aquifers. I mean, I know it's grandfathered in, but isn't there?
That water right, I guess, is so old. It probably would be very difficult to change. You know, first
Maybe we could grandfather it out or something, you know?
grandfathered in. Yeah, yeah. First in use, first in right. It's very hard to change those old water rights. Because
water-
Tombstone really doesn't have any good groundwater to draw from.
Some of that water is actually sold to ranches along the pipeline. There's a ranch south of Sierra Vista that uses that water for cattle tanks.
Mm. I wonder what the volume is. It'd be, yeah, interesting to see if that could reduce that water right a little bit and keep some of that water up in the Huachucas.
So Tombstone is buying water. I mean, Tombstone is selling water to ranchers.
Yes,
How wrong is that?
pretty wrong.
Yeah. It's just, I think we need to limit because, you know, there's birds and animals up in the canyons that need water too, you know,
Yes.
water
There's
for
not a lot
nature.
of protection for water for the environment in our state.
No, and it's something us people that are concerned about water, we need to talk about it.
Yeah. There is a new law where you don't have to take out the water to keep your water right, which was, you know, some people were just using it because they didn't want to lose the right to that water. That's more for surface water, but that was a good step. So the water could remain in the stream and be used by the ecosystem rather than being forced out because someone was afraid to lose their water right. Let's look here at Huachuca City.
And ask that.
Here is a monitoring index or monitoring well. So that was 70, 71, maybe 72 to maybe 2020. That's some real low dips.
And Ann Oust had the question, what is the closest index well to Huachuca City? Not sure if that was what you were just trying to find.
Yeah, this is what we're
Okay.
looking at here. So 72, it was 199. And the most recent was 2020, 221. Not a huge drop compared to some places. So again, when you're looking at the hydrographs, you do need to take note of the dates and the depths. So that's a drop of 21, 22 feet. But if you have a well that's not deep and you hear about that, that could be the drop that does you in because well doesn't go down to 220, it goes down to 200. So that's
So when did the Baba Kamari actually have a base flow going through Huachuca City?
oh, that's such a great question.
Years and years ago.
And where did it cross? What road did it cross?
It crosses Highway 90, just north of the city.
Yeah. That's a wonderful question. I could ask people at the Upper San Pedro Partnership.
Because it's, of course, dry as a bone now.
Was it ever perennial?
I thought it was, but I could be mistaken. I could be misinformed.
Do you know Bob Luce?
No,
He lives near that watershed and is a wonderful photographer. Also takes great pictures. I mean, also writes books. Sorry, thrillers. He may. I'll give you his. Is this Ann?
yes.
I'll give you his contact information. He may know that. He's quite active in water.
The other question I had, you're aware of our series of infiltration basins at the garden. And we got about 800,000 gallons infiltrating at that location. And we talked briefly, you and I, about how long or where that water might, first of all, where that water might go actually. Is it going to go into that groundwater 200 feet deep? Or is it going to hit another layer and be prevented from going into the groundwater? I don't know how deep the wells are for the city. I don't know if they go down 200 feet or whether they go lower than that. But I want to be able to talk with students about these infiltration basins and what they might be doing in terms of replenishing groundwater. Is there anything we can say about that?
Awesome question. I mean, there could be, clay, would I mention that word aquitard? Clay layers, caliche layers that might move the water horizontally to where it's very hard to say. Unless you took like a core sample or something. Or sometimes people they put a isotope in and then they see what they think of is downstream in the groundwater and see if that shows up and when. So you get some idea of the flow of water in the ground, underground. You're also adding soil moisture to that vadose zone though, which is really great. I think we talked about that too. So that infiltration is working to help create moisture in that zone where plant roots are. But whether it gets to the groundwater and where, I can't answer that question. I wish I could. We could look and see if somebody has a better idea. Maybe there's a study I haven't seen regarding the flow of water through that area in the ground. So I will look around for you, Ann.
When they put these monitor wells in, do they record the different types of soil they're moving through as they go down? So that we might get some idea from that, because this is not too far from that monitor well that we were looking at.
Yeah, I have not seen that at all, but that would be something that you could contact ADWR about.
Okay.
Because they are actually quite responsive to things like this. And I will send you someone's, I'll send you Bob Luce, and I'll send you someone's name who I've been in contact with regarding the basins down here.
Okay, that'd be great.
Some corollary data regarding soil type. But and also ask him your question about, where do you think the water that we're infiltrating is going? The other group would be the watershed management group. They did a quite extensive study of Sierra Vista regarding stormwater runoff and how that could be improving things. So if you're all not aware of that, it's a wonderful organization that works with riparian restoration and education regarding rain harvesting and all sorts of stuff up in Tucson. And so I could send you that study that they did. Groundwater infiltration and storm runoff for our actual Sierra Vista area. So that's a great study.
We had one more comment. Megan says, we are looking to buy some land in Elfrida, but we have heard that the wells are going dry due to the large dairy operation that came in a few years ago. So I don't know if you have any commentary on that. I guess that's not a question.
Would be quite cautious about that. The wells are growing dry there. Unfortunately, we don't have enough people reporting them, but anecdotally, I can tell you yes. And I can even mention a few people that I know who have had that happen. Yes, I would be quite cautious about that. You can talk to me further if you'd want on more information about that, and look at the index wells near where you're thinking of purchasing, which is, you know, a shame. Or consider very large scale rain harvesting. When we have in a monsoon, you can actually harvest a lot of water. And there's quite a few people living on rain, just decided not to drill a well, went the other route. So they have a lot of rain harvesting. It's not actually that pricey, regard the difference between large scale rain harvesting and drilling, and you don't have to do it again. So yeah, I'd love to speak to you more about that if you'd like to, Megan.
Janet also mentions, a few years ago, I invested in Source out of Tempe to have drinking water taken from the air. It's a solar operation and the water is very good.
Excellent. I'm glad that's still working, Janet. That's great.
Not only is it working well, but it also, it means I only use the well water for irrigation of plants or trees and washing of dishes and laundry, that kind of thing. So it reduces the amount of water I use, but it certainly improves the drinking water that I have.
Excellent.
Drinking and cooking.
Yeah. Oh, and cooking. Yeah. Yeah. Do they test it for you?
If I request it, they did in the beginning once or twice,
Mhm.
and then it's a matter of my request.
I'd love to see the difference
I
between
haven't
that and your
bothered.
well water. It would be so interesting to
The
see.
well water tastes awful.
Yeah. That is something we need to say
I mean-
before we let you all go, is that there is some
Oh, yeah.
free well water testing happening right now through the Arizona Department of Health Services and WaterWise. Please look on our website for more information about that, or email us if you want to get your well water tested for heavy metals. Well, good to see everybody. Thank you so much for joining us.